So I'm going to start us off with this problem here. I've got our triangle here just to remind us that the angle A corresponds with side length A, it's opposite of it, and likewise with B, and likewise with C. And so we'll be able to refer back to that if we need it. What I have is an angle side right now. I have an angle, another angle, and the non-included side. That'll come into play a little bit more later, but right now this is what we need. What you're looking for is some pair of angle and side combination. And right now I have that. I have angle B and I have side length B. So I've got this triangle here, and let's establish what we're looking for first. How about we find side length A? So what we're going to do is take this angle side pair that we already know. We know angle B and we know side length B, and that's going to let me set up a ratio. The sine of angle B, which is 70 degrees, divided by the 16 inches that it corresponds with, side length B, equals the sine of 33 degrees divided by side length A. Now, to solve for A, we can cross multiply. So I'm going to cross multiply and get 16 times the sine of 33. And typically you don't have to write the dot there to multiply. 16 times the sine of 33 equals A times the sine of 70 degrees. And now we're able to isolate side length A. How can we do that? We can divide by the number that it's multiplied by. Now, you have to realize that sine of 70 does not look like a number, but it is one single number. And so I'm going to divide by that number that side length A is multiplied by. I'm going to divide by the sine of 70 on both sides. Sine of 70 divided by itself is 1, and so that cancels out. And now we've got to go to our calculator. Make sure you have your calculator in degrees before we do this. I am going to do 16 times the sine of 33 degrees and hit enter. And before I write that down, I'm just going to divide immediately by the sine of 70 degrees. And what I get is that side length A equals 9.27. We were in inches. 9.27 inches. Now that we have that, are we able to get anything else? Well, this angle and this side, actually, we don't know. But using the triangle sum theorem, don't forget, you have two of these angles in the triangle already. And so angle C can be solved for pretty quickly. Angle C is 180 minus the sum of your other two angles. And so angle C equals 77 degrees. And now with established ratios, we knew angle B and side B. We now know angle A and side A. And so using that, we can now solve for side C, comparing it to that ratio. My engineering professors used to say, you should as much as possible try not to use information that you yourself solved for. That's because if you use information you solved for, you could compound errors that you made. I'm going to go back to the sine of 70 and its pair, 16 inches. I'm going to use that again and do the sine of 70 degrees over 16, just like I did before, right here, equals the sine of 77 degrees over side C. C times the sine of 70 equals 16 times the sine of 77. I'm going to divide both sides by the sine of 70 degrees. Sine of 70 divided by itself cancels out, and C equals 16 times the sine of 77 divided by the sine of 70 equals 16.59. So C is approximately 16.59 inches. We can add that here. At this point, we've solved for all of the angles and all of the sides. And this is what's considered solving a triangle. Now let's go ahead and do this one. This is an angle side angle case. We know the included side between two angles. What can we start out doing right now? Well, we don't have, I'll call it the A pair for lack of a better term. We don't have angle A and side length A. We don't have angle C and side C. And we also don't have angle B, but we do have side length B. And so none of those ratios is complete right now. First thing you would have to do is solve for angle B using the triangle sum theorem. So 180 degrees minus the sum of the other two angles, which by the way can be written as 180 minus 41 minus 82. That's just distributing the -1 there throughout that parentheses. Angle B equals 57 degrees. We can write our 57 degrees in here. Now I've established a whole ratio. I know angle B and I know side length B, and you're able to do the law of sines now. So the sine of 57 degrees, actually we need to decide what I'm solving for. Let's solve for side length A. And I'll go ahead, instead of making that an X, I'll make it an A. Sine of 57 degrees divided by its side length equals the sine of 82 degrees divided by its side length. When I cross multiply, I get 20 times the sine of 82 degrees equals A times the sine of 57 degrees. And when I divide both sides by the sine of 57, sine of 57 divided by itself cancels out. I get that A equals 23.62 meters. I have this in. This is 23.62 meters. And now I'm able to solve for side length C as well. Using the same ratio, sine of 57 degrees divided by 20 equals sine of 41 degrees divided by side length C. 20 times the sine of 41 equals C times the sine of 57. We're going to divide by the sine of 57 again on both sides. And C equals 15.65 meters. And we can complete that triangle, 15.65 meters. So there are different ways to calculate triangles, any triangle, and we've just done two of them using the law of sines. We looked at an angle side case. We used the law of sines to calculate this. And I have just number signs here because I think it represents pretty well that you need a ratio of one angle to its opposite side. So we have that ratio established here, but not here and not here. But with this one ratio established and two of the angles, you could solve for this angle like we just did, and then you have a ratio, this ratio, to compare to the other two. You're able to solve for x here, y down here, and you've solved the whole triangle. We also did an angle side angle case. This is also the law of sines for the same reason. We don't have an established ratio yet, but we can use the triangle sum theorem to solve for the last angle. And then after that, we do have an established ratio right here. So two triangles that you're able to solve with the law of sines. There are other triangles that we're not able to do with the law of sines, but we'll get to those in another video.